Good morning. This is the 4C Conference webinar series. We're happy to have GHD as the webinar presenter today discussing photochemical modeling. This is a popular presentation over this will be the 11th year for 4C Conference. Over the last 10 years, we've had about 500 presentations. As part of the webinar series, we have chosen about top 100 presentations from the last 10 years to be presented as part of the webinar series. We appreciate the attendance today and very much appreciate GHD representing the presentation regarding photochemical modeling as part of our webinar series. To introduce Mr. Zhang of GHD. Mr. Zhang is an environmental engineer and also has a master's. He's been with GHD since 2006?
2018.
2018, sorry. And we'll be discussing photochemical modeling. With that, I'll have you take it away, Mr. Zhang, and start the webinar for today.
Thank you. Thank you, Steve. Thanks for the great introduction. So everyone can see my screen well?
Yes.
Nice, nice. Okay, so today I really appreciate this opportunity from 4C to give me this chance to present my photochemical modeling topic again on this webinar series. And I understand it's been a challenging year last year for everyone. And a lot of those physical meetings are now moving to online, and this is a really great format for us to connect during the challenging time. And I really appreciate everyone, take your time and, listening, coming, joining us for this discussion today. So, so the overview of today's, presentation, so we'd like to talk about, 5 points. So what is this, inter-precursor trading? And 2 is why inter-precursor trading is conducted. And then the third topic will be why we need to do modeling for those inter-precursor trading, and how to do such a modeling analysis. And finally, how do we look at the results and analyze? So I think, as we all know, the ozone is formed, ground level ozone is formed, due to the NOx emissions, NOx concentrations, VOCs, the organic compounds, with some heat and sunlight, and forms ozone in the ground level. And, ground level ozone, typically, the bad ones, and, apparently we know in here, Houston area, the Houston-Galveston-Brazoria area is a ozone non-attainment area, which poses a lot of challenges in permitting, so you have to look at very strict threshold when doing your projects. So the Houston-Galveston, this presentation, we take the Houston-Galveston-Brazoria, this area, the ship channel area, as an example, but this other idea will be able to transfer to any of the ozone non-attainment area in the United States. So the Houston area, for the 2015, the newest 8-hour ozone standard, we were declared marginal non-attainment as of August the 3rd, 2018. The more problematic standard is the 2008 standard, which we were declared a serious as of September 23rd, 2019. And if the situation does not get any better, we might get into the severe non-attainment area, situation you know, last time I talked about this was thinking about maybe 2021, which is this year, because our attainment date is July of this year. If we still not attain the 2008 ozone standard, we could be, reclassified as severe non-attainment. However, as we all know, what happened last year was due to the pandemic. Lots of the production, was reduced due to at least the first half of the year, and we start slowly, ramped up, reopened the state. We reopened everything, towards the end of the last year. But as we all know, the situation didn't improve, and apparently this winter we still have some challenges dealing with the pandemic. So it's not going to be surprising, the production is still not going to be up to the 100%. So on the other hand, the air quality actually, as a side effect of that COVID, was actually a little bit better than previous years. In the next slide, I'll show, the design value, the monitor design values, and we can look at the trend. Are we going, anywhere worse or a little better? So due to the, let's back to the topic on the serious non-attainment. Due to the serious non-attainment status, the major source threshold for, any project for VOCs and NOx is 50 tons per year, and net out threshold becomes 25 tons per year, and netting threshold, if you have any project, you have to be comparing to the 5 tons per year of, threshold. And the offset ratio, if you are run into non-attainment major projects, you have to buy the offset in a ratio of 1.2 to 1. So that's kind of a lot of, money due to, the high price of the, emission reduction credits. And we are going to discuss about that, in the later slides. Here I have added this slide. If you look at the online, presentation, it may not have this slide yet. I've got this, I add this slide recently, and and after this webinar, I will email this, new updated presentation to Steve, and we can, you can post it there, so we have the updated information. So last time I looked at this value, it was 2019-ish, 2020 last year. We look at the 3-year average from 17 to 19, and we were, the worst case, monitor is 81 ppb. Comparing to 75, it's 6 ppb over. And you can see that we have a good 2017, but we had a pretty, we didn't have a really good 2018, and pops everything up. 2019 was kind of like just like the typical years. Well, we can see 2020 last year, all the monitors reads attainment values. So if don't know if that's a good thing or bad thing, but if the situation continues, we might have a similar 2021, and we'll have 2 years in a row. And although even though the 18 to 20, this 3-year average, we're still looking at non-attainment, but if next year, if we dropped the year 2018, looking at 19 to 21 average, we might be looking at pretty good air quality, and maybe we have a chance of not going into the severe non-attainment. Maybe could maintain the serious, or even looking at some even better situations that we are attained. But I'm sure EPA will want to keep a maintenance status on this area, and see if when production goes up in 2022, 2023, anything will change. So after we talk about all those, the credits on all those, the concentrations. So what is the inter-precursor trading? So in any of the non-attainment new source review, the Texas rule and allows the use of emission credits or discrete emission credits of one ozone precursor to meet the requirements for the other ozone precursor. This is so-called the ozone inter-precursor trading. And in some cases, when we want to build a new site or like have a project, we're short of emission credits, and we need to buy emission credits from the market. And even though we were willing to pay, but sometimes there was short of credits of, like, say, VOC or short of NOx. And this this presentation, we are trying to introduce this inter-precursor trading and modeling, so that we allow using NOx credits for VOC emissions or the other way around. And the current market trend, NOx is less expensive. That was my statement last year. And when I look at the trading history of 2020, and things are a little bit changed, but like the NOx credits are going up because apparently the market seeing us doing all the inter-precursor trading, people tends to use the NOx to offset VOC, and market gets to know this, so the NOx credits also goes up a little bit. And now we may need to consider the NOx limiting factors to make this statement. And we can, example is for here in the Houston area, we are limited by NOx. So typically, if you do modeling will tell you, if you retire 1 ton of NOx, you're probably getting the benefit of more than 1 ton of VOC, retirement. So kind of like using NOx credits for VOC, actually, you can, through modeling demonstration, you can probably save some credits. In that kind of terms, you save some cost. And it's actually a lot of money. This is saying why do we need to do inter-precursor trading? Here are some like trade histories from the year 2016 and 17, and then we can see I'm not going to be too much into that 16 and 17 data. I'll have newer data next slide, but we can see that NOx credits are typically pretty a little bit cheaper than VOC. VOC is pretty high. And in 2017, we do have like an outlier because there was a trade of only $8,000 and trading at 50 tons. That's if we exclude that, the average come back to 106K. And here is the trading data for the 2018-2020, and we can see that NOx and VOC are pretty much kind of like going pretty stable. And NOx, we are seeing when we goes to 2020-ish, we are seeing some price increase than the previous years, and VOCs are stable. Not to say to reduce, but keeping stable, and we can see the NOx average trading price are catching up with VOC. And the price slightly increased in 2020. However, you can see that in the next slide we can also see a more clear image of the trades. But and I pick up those broker prices that typically you sell your facility sell the credits to brokers in a lower pricing, and brokers sell it back to you to other industry facilities at a little bit higher price for their cut. So currently we are looking at very typical broker price of NOx at 145K per ton. Think about that per ton. And VOCs are at about 165 per ton. So the broker price, there is still a gap between NOx and VOC, but I'm not going to be surprised if this gap is also getting closed, in the near future. But we still, by doing the modeling, we still can demonstrate using less NOx for more VOC is possible. So this is a more like a zoomed in, view of the trade price and the volume, and we can see, a lot of trades going from 2018 through 2019, and last year, the trading activity was a little bit slowed down, but apparently, maybe COVID plays a role into it, and we will see how, this year 2021 will look like. And this slide shows all the available emission reduction credits and the expiration dates. And this graph I showed in last year's presentation, the 4C conference. And we can see that there is a lot of things actually, a lot of VOC actually expired or to be used in 2020. And I grabbed the new data and put together this new graph. We can see that NOx credits are actually, availability is getting sparse. We still have this big chunk of VOCs credits here in 2020, expiring 2023. But we are looking at a little bit less, from the year 2024 to 2025. We're looking at there is not much new NOx emissions available, but things can change, and or we can do the other way around. In the case that we are really short of NOx, we can use VOC to offset NOx. But this is all the Houston-Galveston-Brazoria area, and I've looked at actually the trades. Last year, only trading in the Texas are happening in the Houston HGB area. There is nothing happening in DFW. But I have not looked at other areas of the country, but the similar idea could apply. So after we talk about why do we do the inter-precursor trading, that apparently saving a lot of your cost, but now turn to the point, why we need to do modeling for this inter-precursor trading is the reason is to make sure that by retiring one precursor emission reduction credits for another precursor's new emission does not negatively affect air quality. Before, like about 5 years ago, we allowed those inter-precursor trading, like you just go buy NOx to offset VOC, and we qualitatively describe that, hey, for example, this area, Houston-Galveston-Brazoria, is NOx limiting, so I'm retiring NOx and getting some VOC emissions, so actually improves air quality. And TCQ and EPA takes that argument is fine with that, but lately they have been asking for, hey, let's do some photochemical grid modeling, see some ozone modeling, see if really the scientific modeling tells us the same conclusion. So this is the reason that we have to do modeling for this trading to demonstrate it. So how we do this inter-precursor trading, this model. So typically, photochemical grid models that currently on the market is the ChemX and CMAC. The ChemX is developed by a consulting company, and they have maintained the version, and I would say more of the photochemical grid models are done using ChemX than CMAC. CMAC is the EPA maintained kind of like photochemical grid modeling, but both of those are accepted for photochemical grid modeling for the inter-precursor trading, and also used in SIP modeling. Also, these two models are widely used, globally, to evaluate regional and global impacts. And for specifically, not talking about SIP modeling or other global climate changes, we are talking about this inter-precursor trading. So we need to put together 3 model runs to try to demonstrate the inter-precursor trading is valid. So that includes the attainment baseline case, the credit baseline case, and project baseline case. And I'm gonna describe that in more detail in later slides. And at the end, we'll do a comparative analysis between the credit baseline case and the project baseline case to see whether air quality impact is, air quality is impacted or not. So to set up the model runs, so we will, set up this attainment, the AB. I kind of like a little bit reluctant to use a lot of, those jargons or like abbreviations. This kind of like this, because this is already a very niche kind of like a concept, and it just keep talking about abbreviation, getting people confused. But this is the AB means attainment baseline case. We'll set up this case and pretty much equivalent to what the SIP or state implementation plan, run that the state has put together. And the state or the regional agency who conducts a regional ozone model, and they pretty much has those kind of like ozone run done. We create this attainment baseline case for the purposes to verify the model still kind of like valid, kind of like can duplicate the SIP model runs. Well, we're looking for identical results, but apparently not all the time, because of the model updates and all the different ways of compiling the executables. Sometimes we don't get exactly identical results, but if it's close enough, we call it okay to use. And the criteria is the difference from each grid cell day. The results will be less than 0.1 ppb. And I'm going to, talk about what is grid cell day in the later slides. And then, after the attainment baseline case is set up and validated, we're going to set up this credit baseline case and the project baseline case. Here is basically what the models look like. Basically, we take the AB case and we just add. This is a little bit counterintuitive for the credit baseline case, because we're not that taking out the credit. The credit means the source that you are assumed to retire. We're not pulling it out from the attainment baseline case. However, we actually put these emissions back and actually duplicated, maybe double counted, into the attainment baseline case. Basically, model it at its location. That creates the credit baseline. The difference between the emission input from the AB and the CB case is only that we added a few sources into that. And same idea for the project sources. The project sources are a little bit more intuitive, because you are building a new source, so you put the new emissions into the AB case and make the project baseline case. At the end, then we'll do try to analyze. We'll do the comparison analysis to see whether the credit baseline case or the project baseline case has a better air quality, kind of like estimated air quality. If basically the conclusion would be, if the credit baseline case will result in worse air quality than your project, then it is justified to retire your credit. Let's say you retire those NOx for your new VOC emissions. So how do we analyze the results? So we're looking at three metrics, which is denoted here as IPE, IPM, and IP ratio. And again, those are some abbreviations. I'm going to explain that later here. So first, let's pick up from the previous slide that we talked about the grid cell day. So what is a grid cell day? So let's say the model domain is this 2x3 grid, and in the real life, you're never gonna see that simple of a ChemX run. Apparently we have 3 layers, like a continental US, grid, like 36 kilometers by 36 kilometers grid, and then you put in like a Texas, a medium size of 12 kilometer by 12 kilometers nested in there. And if you are doing Houston-Galveston-Brazoria area, you will have a more refined grid, the third grid, typically at 4 kilometers by 4 kilometers, at to kind of like zoom in the region. And in some extreme cases, there are also 1.3 kilometers nested grid, but we typically don't see that in inter-precursor trading models. So you have 6 grids in this example, and you model 3 days. In fact, in the real life, you probably model the whole ozone season, maybe at least like a month or 2. So this is just like a simplified example. It's giving some conceptual idea. So for 3 days and 6, grid, we will have 3 times 6, 18 data points. So actually think about that. If you're in a real life, it's a lot of data to process, and you will typically see in those modeling reports, you have a very long and like appendices that provides every day's results of every like grids, kind of like use like contour plots, colored plots to showing that. So that's why this is the grid cell day. So every grid cell day is kind of like a data points that we will compare in between the 2 model baseline case. So let's talk about the first metrics, which is the IPE. We're calling it overall air quality effects. So we need to, so now that, okay, so let's just think about 3 runs are done. The attainment baseline case, the credit baseline case, and project baseline case. As I just say, they are done. Apparently, sometimes it takes weeks to run all those models. So it's it sounds like pretty simple, but all the model setup and runtime are a pretty heavy burden to do those kind of modeling. Once we got all the grid cell days that we model, we are looking at the AB, the attainment, the baseline model, basically. Look at first. We will pick all those model predicted ozone concentration greater than 65 ppb. Why 65 is it's like a 5 ppb less than the standard. The current standard of 2015 standard of 70 ppb, so we take 65 ppb as kind of like using an analogy to say it's like kind of entry ticket. If you get if this grid cell day gets this entry ticket, it's getting into the entry into the comparative analysis. We'll look at it through the credit base, project base. But if that grid cell day does not meet this 65, we are not looking at that, because because you will have a lot of lower number, like say 40 ppb, 30 ppb in some good days, but we are only interested in the days that are possibly being over the standard. And why we are trim that is another issue, like it is another question. We trim all those concentration at 65 because in all those smaller numbers, if you do all those comparisons, it may skew the curve, and you will get some biased results, and that you probably you spend too much effort and energy to evaluate those grid cell data that not going to make any significant contribution to any like exceedances of ozone concentration. Like this is a quick illustration of the attainment baseline case. So here the 18 data points I've provided here. So how many grid cell days that the data points needs to be considered? Let's look at this. So this is one more than 65. This one barely didn't make it. those 70s certainly needs to make it, and this 70, so that's it. So one thing I'd like to be clarify here is, so when we are talking about project-based case or credit-based case, okay, apparently when you add some emissions in there, you will probably looking at some concentration increase. The example here is we just talk about this 64.5 did not make the 65, but in the project baseline case, it did make 65. Are we going to do the comparison to pull this back and put this back into the entry pool? The answer is no, we're not doing that. We only looked at the baseline, the attainment baseline case, to pick up all those questionable grid cell days, and then we run the other two projects and the other runs and compare the difference between there. So that is the grid cell days, or which grid cell days to be considered. So let's calculate all the, if the IPE, which is overall air quality. So we need to look at all those grid cell days that we picked and do this summation. So we take the credit base, for example, for this case will be all these changes, like say 79.2 minus 78 point, that's 1, right? So we will sum all those credit cases, the increase that comes up that the effects of the credit, that's the EC. And we'll do the same analysis for the project-based case. Okay, so your projects, how is your project's effect to the overall air quality? That's your effect of the project, EP. And we'll do, after we sum up all those and do this comparison, we do this, we use the EC to minus the EP. That is your IPE. The goal is that IPE greater than 0 or equal to or greater than 0. That means your project, resulted in a better air quality impact than the credits. So it's justified to retire those credits and build your project. So this is this needs to be done. The IPE needs to be done at all grid cells that exceed the 65 ppb at your baseline. So let's talk about the second metrics, IPM, which is the monitor design value. So in the model, you also will be able to find those grids that the monitors that surrounded by typically like a 3x3. In the grids, those grids contain some monitors. Okay, so we look at there's a more complicated than shown on this slide, but the basic idea is look at 3x3 or 5x5 or sometimes 7x7 grids to like extrapolate the model, the results for the design value of each monitors that we have. Remember that I'm showing this all the monitors list that in the Houston-Brazoria Galveston area, and we need to look at all the monitors on that list. So for each of the monitor, you need to also look at, okay, so what is the predicted credit baseline case design value, and what is the design value if you just build your project? And you need to do this, you need to use the credit case base design value to minus that project baseline case. And the goal, very similar idea, is to, the goal is needs to demonstrate that the credit actually have a higher, design value than the project. That way it is justified to retire those credits. So the last metrics we are looking at here is the ratio. So what is the ratio means is the credit, it's the credit surrender divided by project emissions. So it's not necessarily a one-to-one trade, a one-to-one, retirement. Like if you buy 1 ton of NOx, how many, equivalent is, what is equivalent, kind of like a project emission you can build, right? So the ratio has to be fixed before the model run, instead of to be determined after the model run. Kind of like we had some misunderstanding during some projects that we have the model run once, and okay, so the client will ask, okay, so can I surrender less credit because I'm looking at all of the equations, like the requirement is greater than zero, greater or equal to zero, but apparently client will want to save as much cost and surrender as less credits as they can. So we'll have to, they'll want to ask, what's the minimum credit I have to surrender? They think, hey, can you look out that data from the model you just run? Unfortunately, the answer is no if you do a directly, analysis like this. There may be some, source apportionment, kind of like, analysis you can do within ChemX or CMAC, but, typically the previous, the model approach was those, EP and TC looking for. So at the end of the day, you have to run different iterations of the model so that to find out the minimum credit to surrender. That is also something to think about, because each model run takes a long time. So what is the minimum trading ratio? Apparently, depending on that state agencies. I have done a project in Louisiana, and the state requires at least a 10% cushion that they say, even though, regardless of whether this is a NOx or VOC limited, if you want to trade, using NOx to cover VOC, I want you to at least surrender at least the same amount of, tonnage of NOx as your VOC projects, and add a 10% cushion. So the minimum, ratio would be 1.1 to 1. If you do the modeling. And in fact, that project was actually, we were running into about 1.5 to 1. That area is more VOC limited. So retiring, NOx is less effective than retiring VOC. But unfortunately, that was the case, that the client has only NOx credits to use. But it's still a good project, because if they don't use those NOx credits, they'll expire. So we find a really kind of like a pretty good places for them to use their NOx credits, although they had to surrender probably about 1.5 tons NOx for every ton of VOC construction. But in Texas, the TCQ does not have that mindset. And on December 2018, for the first time, a trading ratio of less than 1 is approved by the TCQ and EPA. That is, the actual project was 1 ton of NOx used to offset 2.4 tons of VOC. So that is actually pretty good, because considering NOx, this is a NOx limiting environment here, and scientifically, yes, if you retire NOx, it's more effective, than the VOC emissions in the same tonnage. So that actually creates a good opportunity, even though just show the NOx price are pretty much the same as VOC, but 1 ton of NOx price is still much less than 2.4 tons of VOC. So there is also, there's some other topics, there is also some other, tradings and modeling. That interbasing trading was also done in the past, like about a few years ago. People have been using Dallas-Fort Worth credits to offset HGB emissions. In fact, modeling, but that project wasn't a combination. They use part of the Dallas-Fort Worth credits and use part of the Houston-Galveston credits to offset Houston-Galveston, projects. And the model actually shown very minimal benefits if at all, you know, of credits retired in DFW to the Houston-Galveston-Brazoria area. It's not surprising. It's considering the distance. And that was before the first, you know, less than 1 NOx to VOC ratio was approved. You know, by that time, you know, like TCQ, you know, the EPA were not very comfortable of, you know, retiring less NOx for VOC. So this kind of like, you know, the modeling also shown it's actually some of the Dallas Fort Worth credits. This is, you know, is basically on paper kind of like a reduction because it does not really, on scientific, does not offer any benefit of Houston-Galveston-Brazoria air quality impacts. But with that, it actually basically makes up the number of tons that you have to retire in the Houston-Galveston-Brazoria area. And you basically get some Houston credits, and those Houston credits are already enough to offset your VOC project. But when TCQ and EPA not allowing less for more, you know, we, you know, grab some Dallas credits to play into this, you know, argument. But now that the trading ratio less than 1 could be allowed, do we still really need interbasin trading and modeling? Maybe, you know, not that necessary. I think that's pretty much my presentation. And to summarize, you know, there are like a different limiting mechanism for ground ozone information to provide the justification to use, you know, inter-precursor trading. You know, apparently if you retire, you know, because it's like a two precursor to make ozone, so scientifically it makes sense. Sometimes you retire NOx for VOC, and 2, cost difference between VOCs and NOx credits actually creates an opportunity. The market activities tend to close or had already closed the gap, but the modeling opportunity still exists as the ratio. You can play with the ratio. This 4-step IPT modeling, including this attainment, credit, and project baseline runs, and at the end of the comparative analysis is the current approach that we need to demonstrate the project has no negative impact to the air quality. So that is all my presentation. And again, thank you so much for the opportunity for present today. And I'm happy to take any questions that we have.
Okay, thank you very much. It does not appear there have been any questions asked. A question I may have is the timeline. If a company is planning on, you know, has a 2 to 5 year time horizon on capital project planning, how long does this modeling take, and when should a industrial company engage GHD if they have a project that they're planning? Is that a 1 year, 2 year, 3 year time?
You know, for those projects, you know, it's not as intensive as you know, SIP modeling, like state SIP modeling that typically takes. You need to grab all the emissions inventory, process through smokes, you know, process, you know, meteorology through WRF, and, you know, basically you do the legworks for the SIP model. But, you know, for these projects, as I mentioned here in, you know, we are creating all these projects based upon the case that's already been built by the state. It's basically the AB case, the state case, plus your credits. You know, we add some sources into there. It's significant. It's still significant more efforts than, you know, typical dispersion modeling using AirMod, and considering, you know, using, you know, setting up, you know, all those runs in Linux, running Chemex or CMAC. It takes a little longer than AirMod to run, but, you know, right now we GHD is we are starting to build some supercomputer systems to allow much quicker runs. So I would say our runtime could significantly reduced due to we can have access to a much stronger computing power than a few years ago. So really, the modeling should not be a limiting factor in timing, and we should be able to to do these projects with like the last project I did in the Louisiana takes about half a year, and I'm seeing because we had 3 or 4 iterations. Each iterations took more than like each runs were almost like a week long. Considering every iteration you have 3 runs, that's pretty computing power expensive. And now that we are building our new system, it could run much faster. So I would say can reduce from 6 months to maybe 3 months. However, it all depends on we also rely on client provide us all the readily available information, and it's not surprising clients changing information from time to time, and we definitely understand that and work with them. And on more of the things you need to think about is your permitting process, the time frame, and as you know the ERCs has expiration date. You need to be well planned ahead. Like for example, if somebody's aiming to use these, that's good. Like you have still 2 years. But if somebody is looking at using some credits over here, see 2021 expiring in May or July, then you will be definitely running into a very tight time frame. And now is January. If somebody wants to use the credits in expiring July, we need to start to planning now. But if you are aiming at this credit, then we still have a couple of years time, and it definitely modeling should be able to finish in that time frame. And Steve, thanks for also bringing up that cost. I would say it's definitely going to be more expensive than doing a PSD dispersion modeling price. But looking at how much more expensive, we are not looking at too much like too terrible pricing. And considering considering the benefit you got from you're saving from your trade, like like say let's say just if you can retire 1 ton of NOx to gain 2 tons of VOC, each ton of VOC you saved $130,000, and for those non-attainment projects, you're at least looking at a few like 20 tons of credits. And if you can get it from like NOx, you save 20 times $130,000. And the modeling project will be only a small portion of that.
Correct. It's not something that you would, if you had to buy credits, you would certainly want to know that you're buying the least number of credits required, and that's the key to answering that question is what is the least number of credits required is conducting inter-precursor trading modeling. Okay, thank you very much. This is a very interesting presentation, and as you know, emission reduction credits is something that is near and dear to my heart. At one point in time, we had generated about 1/3 of all emission reduction credits on the market when I was at the Sage Environmental Consulting. We were at the front end of this emission reduction credit trend. So it's a great presentation, and certainly anyone that has to do trading, anyone that has to buy ERCs is going to be interested and in need of your services. And we of course also did the dispersion modeling. At one time we owned CHARM and the chemical hazardous air release model.
Mm-hmm.
And this modeling is not trivial, and this modeling is not something to be done on a one-off basis. If you don't do this modeling regularly, the intricacies of the model can certainly present difficulties to someone that is not a professional and doesn't do this full time.
Yeah.
So we appreciate your expertise. I appreciate you bringing your expertise to the webinar today. Thank you to GHD, and thank you for being an exhibitor at the conference also. And we appreciate all the other exhibitors and sponsors. And again, if would love to have and see all of the people on the webinar today at the conference in Austin, August 18th to the 20th, and look forward to seeing you there also. Thank you all very much, and we will now stop the recording